Okay, so this is lesson 13. Lesson 13 was the exam on the syllabus. And what I'm going to do is go over the exam questions. So problem 1 is to find some limits. And the first is a rational function, 17x cubed minus 15x squared plus 100x plus 21 over 34x cubed plus x squared minus 9x plus 11. So this is a quotient of 2 cubics. Both numerator and denominator have degree 3. And we know that the limit as x goes to infinity of a rational function where the numerator and the denominator have the same degree is just the ratio of their leading coefficients. One way to see that, I mean, this is essentially the proof, though you didn't have to work it out, is to factor out an x cubed from the numerator and the denominator. So if you factor out x cubed from the numerator, you get 17 minus 15 over x plus 100 over x squared plus 21 over x cubed. And if you factor x cubed from the denominator, you get 34 plus 1 over x minus 9 over x squared plus 11 over x cubed. And you see that the x cubes cancel. So it's just this ratio. And as x goes to infinity, all 6 of these terms go to 0. So the limit is just 17 over 34, which is a half. And that's the answer. Any questions about that? Okay. B, we take the limit as t goes to 1 of t squared minus 3t plus 2 over t squared minus 1. And in this case, you can't just plug in t equal 1, you get 0 over 0. But you observe that these polynomials in the numerator and the denominator both factor. T squared minus 1 is t minus 1 times t plus 1. And t cubed minus 3t plus 2 is t minus 1 times t minus 2. And again, these two terms cancel. So we're left with t minus 2 over t plus 1. And as t goes to 1, this goes to minus 1/2. That's the answer. Okay. And C is the fundamental trigonometric limit. The limit as theta goes to 0 of sine of 18 theta over 21 theta. And we know what the answer would be if we had the sine of 18 theta over 18 theta. But we don't, we have 21 theta. But if I write it like this, 18 theta over 21 theta, and these cancel, I've just rewritten this in a very simple way. Actually, I don't even need these thetas. 18 over 21 times 1 over 18 is 1 over 21. This is a constant. I can take this outside. 18 over 21 times the limit as theta goes to 0 of sine of 18 theta over 18 theta. This limit is 1. So this is 6 over 7. That's the answer. Okay. Questions about any of this? Okay. Problem 2 is to compute some derivatives. So the first function we have is just a polynomial. F of x is 7x to the 4th minus 5x squared minus 300x plus 21. And when you differentiate, well, you're just differentiating a polynomial. It's 7 times the derivative of x to the 4th, which is 4x cubed, minus 5 times the derivative of x squared, which is 2x, minus 300 times the derivative of x, which is 1, plus the derivative of 21, which is 0. So this is just 28x cubed minus 10x minus 300. That's all it is. Part B was the function h of t equals e to the t times the square root of t. So this is the product of two functions. If you like, you can write square root of t as t to the power 1/2. So then you use the product rule. It's the derivative of e to the t, which is e to the t, times t to the 1/2, plus e to the t times the derivative of t to the 1/2, which is 1/2 t to the minus 1/2. So if you factor out an e to the t, you get the square root of t plus 1 over 2 times the square root of t. And if you want to put this over a common denominator, 2 times the square root of t, you get 2t plus 1. But any one of these forms is okay. This is just a little bit prettier, perhaps. Okay. Questions? C, we have a quotient. R of x is cosine x over x. So by the quotient rule, r prime of x, you have x squared in the denominator, and in the numerator is the derivative of cosine x, which is minus the sine x, times the denominator plus minus the numerator times the derivative of the denominator, which is 1. So that's the answer. And D is the chain rule. S of x is e to the x to the 7th. So S prime of x is the derivative of x to the 7th, 7x to the 6th times ex to the 7th. So those are the answers. Problem 3 is to compute some higher derivatives. So in A, we have the function f of x is x squared sine of x. We want the second derivative. That means you have to differentiate twice. The first derivative by the product rule is 2x sine x plus x squared cosine x. So the second derivative, you differentiate again. When you differentiate this by the product rule, we get 2 sine x plus 2x cosine x. When you differentiate this by the product rule, you get 2x cosine x minus x squared sine x. So this is 2 sine x plus 4x cosine x minus x squared sine x. That's the second derivative. In part B, we want to compute a third derivative. We have the function f of x equals x plus 1 over x, which is like x plus x to the power minus 1. The first derivative, the derivative of x, is 1, and the derivative of x to the minus 1 is minus 1 x to the minus 2. The second derivative, the derivative of 1 is 0, and the derivative of x to the minus 2 is minus 2x to the minus 3. So we get 2x to the minus 3. And the third derivative is 2 minus 3x to the minus 4. So minus 6x to the minus 4, or minus 6 over x to the 4th. Whichever you prefer. Okay. Question 4. We have a curve y equals 4x times x squared minus 1. So this is a cubic curve. Of course, it's of degree 3, 4x cubed minus 4x. So we know the graph is going to look something like that, right? Roughly. That's what we know. Find the slope of the tangent line to the curve at x equal 1/2. So the tangent line at x equal 1/2 has slope. The derivative of the function dy dx evaluated when x is equal to 1/2. What is dy dx? Dy dx, you differentiate this, you get 12x squared minus 4. And if you evaluate this at x equals to 1/2, you get 12 times 1/2 squared minus 4. That's 12 over 4 minus 4 is 3 minus 4 is minus 1. So the slope at x equal to 1/2 is minus 1. What's the equation of the tangent line? It's y equals the derivative at 1/2 times x minus 1/2 plus the value of the function at 1/2. The derivative is minus 1 times x minus 1/2. And what's the value of the function at 1/2? Well, if f of x is 4x cubed minus 4x, f of 1/2 is 4. 1/2 cubed is 1/8 minus 4 times 1/2. That's 1/2 minus 2 is minus 3/2. So this is minus 3/2. So this is minus x plus 1/2 minus 3/2 is minus x minus 1. So let me just check my work, since there's a lot of arithmetic and it's easy to make a mistake. Our function is 4x times x squared minus 1. When x is 1/2, this is plug in x equal to 1/2, you get 2 times minus 3/4. That's minus 3/2. That's what we got. That's the value of the function of 1/2. The derivative, 12x cubed, 12x squared minus 4, when x is 1/2, is minus 1. So this line is y equals minus 1/2 minus x minus 1. And you notice when x is 1/2, y is minus 3/2, which is exactly right. And then we just want to sketch the curve and the tangent line. So let's just look a little bit more closely at our function. We have y is 4x times x squared minus 1, which is 4x times x minus 1 times x plus 1. So this is equal to 0 when x is either 0, 1, or minus 1. So this function has zeros at these points and is 0 at 0. When x is 1/2, it has the value minus 3/2. So this curve is going up, down, and then up again. And at this point, the tangent line is minus x minus 1. It's this slope. It's the line through minus 1 with slope minus 1. So that's the tangent line. So you don't need a computer, you don't need a calculator, just elementary high school algebra together with a little bit of calculus, and you can get a nice idea of what this curve looks like around the point x equal to 1/2. Any questions so far? Okay. Problem 5, we have a function f of x equal to x squared over x squared minus 1. And the first problem is to find the intervals where the function is continuous. Well, if you look at this, the denominator factors, and the denominator equals 0 when x equals 1 or minus 1. So the function is not defined at those 2 points, but it is defined and continuous everywhere else. So f of x is continuous on the intervals. So here's minus 1, 1. Except at those 2 points, the function is continuous. So from minus infinity to minus 1, from minus 1 to 1, and from 1 to infinity, these are the open intervals, so they don't include these points, plus and minus 1. So those are the intervals where the function is continuous. And you have vertical asymptotes at these points of discontinuity, because as x approaches 1 or minus 1 from either side, this is going to plus or minus infinity. So we have vertical asymptotes at the lines x equal 1 and x equal minus 1. So for example, if x is bigger than 1, x squared minus 1 is positive. Function is going to plus infinity. When x is between minus 1 and plus 1, x squared minus 1 is negative. This is going to minus infinity. And when x is less than minus 1, x squared is bigger than 1. This is positive, and you're going to plus infinity. So you have vertical asymptotes at these two vertical lines. And what about horizontal asymptotes? That means you have to look at the limit as x goes to plus or minus infinity of x squared over x squared minus 1. Just to see very clearly what this is, I could write this as the limit as x goes to plus or minus infinity, x squared minus 1 plus 1 over x squared minus 1. I just added 0. That's the limit as x goes to plus or minus infinity. This over this is 1 plus 1 over x squared minus 1. This is going to infinity, so 1 over x squared minus 1 goes to 0. So this limit is 1. So we have horizontal asymptotes, one horizontal asymptote. The horizontal line, y equals 1. And these vertical lines are the vertical asymptotes. Okay. Questions about that? Excellent. Let's look at number 6. Number 6 is to use the definition of the derivative, which I wrote down for you, the limit as h goes to 0, f of x plus h minus f of x over h. And use the definition of the derivative to compute the derivative of x squared minus x. So everyone knows the answer. X derivative is 2x minus 1. But that's not the question. The question is to use this definition. So f prime of x, this is the limit as h goes to 0 of f of x plus h. So f of x is x squared minus x. So f of x plus h is x plus h squared minus x plus h minus f of x, which is x squared minus x over h. We have to compute that limit. So let's just expand this numerator. X plus h squared minus x plus h. This is x squared plus 2xh plus h squared minus x minus h. That's what's in there. So this is the limit as h goes to 0 of x squared plus 2xh plus h squared minus x minus h minus this, minus x squared plus x. And now again, we see some cancellation. Plus and minus x squared cancel, minus x and plus x cancel. So what we're left with is the limit as h goes to 0, 2xh plus h squared minus h over h. You can factor an h out of the numerator. You get h times 2x plus h minus 1 over h. The h's cancel. So this is the limit as h goes to 0, 2x plus h minus 1. H goes to 0, leaves 2x minus 1. Which is exactly what you would expect. because you know the answer to begin with. And the last question, it just involves using simple calculus to solve an equation of motion. We have the position of a freely falling particle at time t, that is the height above the ground, is minus 16t squared plus v naught t plus s naught, where s naught is the initial position and v naught is the initial velocity. So we're told that a silver dollar is dropped from the top of a building 1,296 feet tall. So the initial position of this falling silver dollar is 1296. And we're just dropping it. There's no initial velocity. So the initial velocity is 0. So the position function for our coin is minus 16t squared plus 1296. And the velocity, you differentiate, is minus 32t. So these are the position and velocity functions for the coin. What is the average velocity from time t equal 1 to time t equal 2? It's just the height at time 2 minus the height at time 1 over the time interval, 2 minus 1. What is s of 2? Minus 16 times 4 plus 1296 minus the height at time 1 minus 16 times 1 plus 1296. These cancel. You get minus 48, and 2 minus 1 is 1. Minus 48 plus 16 is minus 32 feet per second. That's the average velocity from 1 to 2. But the instantaneous velocities, v of 1 is minus 32, and the velocity at time 2 is minus 64. Oops. This is 16 times 4 is 64. So I should do the arithmetic right. Minus 64 plus 16 is
You
minus
had me worried there for a while.
48. Yep. Okay, now. Thank you. Make sure you correct me when I do something silly like that. What's the time required for the coin to hit the ground? Well, coin hits ground when the height is 0. And when is the height equal to 0? So S of t, which is minus 16t squared plus 1296, equals 0 when t squared is 1296 over 16. What's 1296 over 16? Let's see. If I divide by 8, I get a 2. And this goes 1. 8 into 49 is 6. 8 into 16 is 2, is 81. So t squared is 81. So t is the square root of 81, or 9. So it takes 9 seconds, according to this, for the coin to hit the ground. And what is the velocity of the coin at impact? The velocity when
Professor, hold on. One question.
Yes.
Can't you simplify 1296 over 16?
Yeah, you get 81. It's 81.
No, I mean simplify it before you, because remember it's t squared. So
Right.
can't you like down the exponent into a single t?
Well, you'd have to take the square root of 1296 over 16.
So if I did it that way, would that still be okay?
Did you get the right answer?
No, I actually left it as a square root of 1296 over 4.
Well, it's really, so t is the square root of 1296 over 16, which is square root of 1296 over 4. Like that? That's how you left it?
Yes, sir.
That is completely correct, even though it's not very pretty. So you won't lose any points at all.
Okay.
That's
okay.
correct.
All right. Thank you.
Yeah, I mean, because if it's the right answer, it's the right answer. You can't just argue that you don't like the appearance. It's like, what the hell? Right. And what's the velocity of the coin at impact? Well, if the impact is at time 9, it's minus 32 times 9. 9 2s are 18, minus 288 feet per second is the velocity at impact of the velocity of the coin at impact when it hits the ground. Okay. Questions about that? Okay.